Hello. Today I'm going to go over the parts of kelp and a kelp forest, structure and function, and kind of compare that to a forest on land and just some of the similarities and some of the differences. Okay, so let's start with the top here. So we have the surface of the ocean. So we know above this surface, this is all air. So I'm going to write air. And the top of the kelp forest, just like a terrestrial forest, is called the canopy. So I'm going to write kelp canopy. And you can see it kind of spreads out. Which makes sense because the kelp is going to go through photosynthesis. Just like trees at the top will spread out to get good light, the kelp is doing the same kind of thing. Each of these leaves are called fronds, and this last frond, the fronds that are at the very end are called apical. Apical just means that it's at the furthest point. Apical frond. And now we get below the surface of the water here. So this is still the canopy. So we're going to label this whole section the Canopy Zone. So I'll turn this sideways. Canopy Zone. Again, that's the top. That's where you're going to get most of the light for the kelp. So it's good that there's a lot of these fronds that go out to the side. Let's see. Let's go a little bit further down now. Now we're below the canopy zone. This is the Stipes Zone. And we call it that because these long, looks like branches, are called stipes. The difference is, unlike a plant which can transport nutrients through branches, the stipes don't transport. So not for transport. They are just there to support. They're just there to support the plant. Okay, so they're not for transport. They're there to support the structures of the plant. And then we get down to the fronds. I talked about the leaves being called fronds. They do go through photosynthesis. So they're going to make nutrients and foods through photosynthesis, just like a normal plant would. The frond edges, you can see here the edges of the frond. They are serrated. And the reason they're serrated is to mix the water that goes by the fronds. So kelp don't pick up nutrients from the soil or from the ground or from the air like a plant would. They're going to get all their nutrients, all their components are going to be in the water. So by mixing up the water as it goes by the leaf, you're getting a maximum amount of nutrients to the leaf or the frond surface. Let's see. Over here, so we already know this, we're in the water at this point, the water column. And then it's pointing to these, this image here is pointing to these bulbous sacs that are at the bottom of the fronds. And these are called pneumatocytes. Or pneumaticist. These are gas bladders. And why would the kelp want gas bladders? For flotation. The flotation is going to help raise those fronds up towards the surface closer to the sunlight because it needs sunlight for photosynthesis. We have some sporophytes or sporophylls down at the bottom for reproduction. The kelp is going to be anchored to a rocky substrate. That just means it's going to be attached to rocks, right? Rocky substrate. It's not going to be attached to sand. It's not going to be attached in the mud. It'll be holding on to exposed rock. And that area, the structure that holds onto the rock, is called a holdfast. Now they kind of look like roots, but they don't function like roots. They're only there to anchor the kelp. They have no absorbent properties like roots. No absorbent like a root. Roots take in water mainly, but other things through the soil and transport it up to the rest of the plant. The holdfast does not. Strictly there to keep the kelp in place. All right, so that's the basic anatomy of the kelp and the functions of the parts of the kelp. If you have any questions, let me know. Thank you very much.